Part B. So the first step is to compute so let this be a sub k. So we compute the limits of a sub k. All right, and then you can see, remember the growth rate. We have k to the k, that's the fastest. Then k factorial. So actually the numerator grows faster, and then what happened? Oh, this quotient just goes to infinity, right? So here we can say diverges by divergence test. And we can stop right here for this problem because we already know that the series diverges by divergence test. But however, I want to show you how about we use ratio test. Okay, so what happened? We're gonna see using ratio test. Okay, so if we want to use ratio test, R is limit k goes to infinity of a sub k plus 1 over a sub k. Okay, and absolute value of that. But because in our example, the terms are already positive, what is a sub k plus 1? We replace k by k plus 1. So it's k plus 1 to the k plus 1. Here we have k plus 1 factorial. The bottom we have a sub k, so that's k to the k over k factorial. Okay, so here we have, let's split the terms. So we have k plus 1 to the k, and we can split one factor of k plus 1. The bottom we can split the k plus 1, and then we have the k factorial. K to the k, we can put it at the bottom. K factorial, we can put it on the top. Okay? So now what happened? Can you see k factorial cancel? And k plus 1 cancel? So we get the limit k goes to infinity of k plus 1 over k. And what is that? Well, we can split, so it becomes 1 plus 1 over k to the k. If you can remember, if you can remember the limit, k goes to infinity 1 plus x over k to the k. This is actually e to the x. Okay, so this is actually e to the x. So that's why in our example, this is e. And what happens if we get e? If r is e is actually greater than 1. So because the ratio is greater than 1, what can we say? The series diverges, okay, by ratio test. You see, we have the same results as the divergence test. Maybe some of you will ask, okay, what happened if I don't remember that the e to the x formula? Okay, it's all right. Well, because you see k in the base and in the exponents, what are you gonna do? By the way, this is indeterminate form, 1. So when this goes to 1 and k goes to infinity, so this is indeterminate form 1 to the infinity. So what do you do is, for this indeterminate form, you're gonna apply ln. So here are more details if you forgot this formula. Okay, so we apply ln. Okay, we compute the limit and we apply ln to it. And what's the good thing about ln? It can bring the power down in front. So we have k ln of 1 plus 1 over k. Okay, so now when k goes to infinity, this is infinity times 0. When you see infinity times 0, you want to move one of the factor downstairs. Okay, so which factor do you move? Well, the ln of 1 plus 1 over k is so big. We don't want to move the big guy, so we move the small guy. But when we move, we also need to flip it. So it becomes 1 over k. Okay, now, can you see when k goes to infinity, we get 0 over 0, so we can use L'Hopital's rule. So what is L'Hopital's rule? We take the derivative of the top over the derivative of the bottom. The derivative of the top, okay, chain rule with the u is 1 plus 1 over k. So derivative of ln of u is 1 over u times u prime. But derivative of 1 is 0. Derivative of 1 over k is minus, right? 1 over k is like k to the minus 1. So we have minus 1, k to the negative 2. So that's minus 1 over k squared. The bottom, same thing. Can you see that these guys cancel? So we have the limits, k goes to infinity, 1 over 1 plus k. Well, this guy goes to 0, so this guy goes to 1. Okay, so that's why the limits 1 plus 1 over k to the k. This is like e to the ln of that. But we know ln of that is 1, so this is like e to the 1, so that is e. So you can see it's the same answer. Okay. All right. Next, let's continue with part C. Okay. So part C. So you can see here we have more interesting because the terms alternate. So okay, first step we compute. So if the terms alternate, this is gonna be a sub k, right? So when we compute a sub k, okay, now let's see what is the numerator. Well, numerator is polynomial, but the denominator is exponential function. We know exponential function grow faster. So if the denominator grow faster, what happened? We get 0, okay? So it means we need to go to the second step and use ratio test. Okay, so I hope all of you can pause the video and try to work on this problem first. Are you done? Then let's continue and check our work. So this is a sub k plus 1, a sub k, and then the absolute value. So here, actually, the absolute value is useful, okay? Because with the help of absolute value, the minus 1 to the k is just become 1. So a sub k plus 1, we replace k by k plus 1. So we have k plus 1 to the 5th. And then we have 3 to the k plus 1 plus 1. So k plus 2. Okay, so this is a sub k plus 2. And then the denominator, we have the same thing, k to the 5th, 3k plus 1. Okay. Now, how do we split? Well, k plus 1 to the 5th, stay here. Don't multiply it out. You don't need to. Okay? And 3 to the k plus 2. Because our goal is to cancel with this. So, how do you split? I split the 3k plus 1 and the 3. Okay? So, if in the bottom, if you see 3 to the k, then how do you split? You split 3 to the k times 3 squared. Okay, so when we split, keep in mind our final goal is to cancel with the terms downstairs. Okay, so, and then k to the fifth is here, and then 3 to the k plus 1 here. Okay, let's start to cancel. So this guy's gone. Okay, so, oh, my line is so long, too long. Okay. All right. So we have k plus 1 to the fifth on top and 3k to the fifth in the bottom. So you can see what's the dominant term of numerator. We have k to the fifth. How about dominant term of denominator? 3k to the fifth. Okay, so what happened? Yeah, so those are the dominant terms. So we have k to the fifth over 3k to the fifth. K to the fifth cancel. We have 1 over 3. 1 over 3 is, I ran out of space. 1 over 3 is less than 1. So if our ratio less than 1, what do we say about the series? Yes, the series converges by the ratio test. Do you get the same answer? All right, let's continue. Okay, so this problem, first step, we compute the limit of the a sub k. We have a constant numerator and a denominator going to infinity. So the answer is 0, okay? And then second step, okay, if we use ratio test, what happened? We get r is limit k goes to infinity, a sub k plus 1 over a sub k. So that equals to limit k goes to infinity. When we replace k by k plus 1, 3k plus 1. Don't forget your parentheses. And at the bottom, we have 3k plus 4. Okay, so what happened to the numerator? So this is 1, and then the bottom we have 3k plus 3 plus 4. So that's like 3k plus 7. And then 1 stay there, 3k plus 4 become the top. Okay. So now what happened? When k goes to infinity, well, the dominant term of numerator is 3k. The dominant term of denominator is also 3k. So when we let k go to infinity, we just get 1. Okay? So, wow. According to our ratio test, if our ratio is 1, then the test is inconclusive. So which means you should not use ratio tests for this problem. Okay, so here you can see we usually use ratio tests when you see like a to the k, k factorial, k to the k in the problem. Do you see those in the problem? No. And actually 1 over 3k plus 4, are you able to integrate? Yes, so actually this is an integrable function. We should not use ratio test. We should use integral test. Yeah, sometimes you use a test and you see the answer is inconclusive. Don't just leave the answer like that and then think you're done. No, you're not done. It means you used the wrong test. So try another test until you get the answer, whether the series converges or diverges. Okay, so integral test, you first define the function, replace k by x. And in order to use integral test, you have to mention the conditions, the hypothesis of the integral test. Well, this guy is the 3 hypothesis, continuous, positive, and decreasing. Okay, then we can evaluate the integral from 1 to infinity, 1 over 3x plus 4. And here, what do? We use u substitution. U substitution, you let this guy be u. Then du will be what? 3 dx. So when you multiply by 3, you also divide it by 3 on the top, right, in front of it, right? So that's why here we get, by the way, we have infinity, so replace it by t. So you have 1 over integral, the x value is 1, the x value is t, and then you have 1/3 du over u, and that is ln of u. U is 3x plus 4, okay? And we have absolute value here. Evaluate from 1 to t, because now we get the x back. And so that's the limit. T goes to infinity. 1/3 ln of 3t plus 4 minus 1/3 ln, when you plug in x is 1, then you get 3 plus 4 is 7. So when t goes to infinity, natural log goes to infinity. Okay, so it goes to infinity. What is the answer? Infinity. Wow, that means the integral diverges. So by integral test, the series also diverges. Okay, so this is the answer of this problem. Okay, next, let's go up and talk about root test. Okay, so root test is suppose the infinite series. Usually you use the root test when your series looks like something to the k. Okay, and then what do you do? So remember, this is like a sub k, and then what do? You let q, the root, to be the k fruits of this guy. Well, see, if you apply the k fruits and the k power cancel, you just get the expression inside of it. Okay, and depending on the q values, if the q is between 1 and 0 but less than 1, okay, then the series converges. If q is greater than 1, including q is infinity, including the limit is infinity, then the series diverges. If the q is 1, the test is inconclusive. It means we should use other tests. We should not use root test. You can see this guy is it's actually the same with those guys. So those criterion is very easy to remember. Okay, so small, r is small. How small? Smaller than 1. Then series converges. If the ratio is big, ooh, diverges. But it's 1 at 1. Oh, we don't know, inconclusive. Okay, so small converges, big diverges. 1 is like the boundary. We don't know. Okay, so keep those in mind. Okay, so let's look at our example. Okay, all right. Okay, so let's look at this example. All right, so first, you can compute the sequence, the limit of the sequence. So this is a sub k. Wow, what happened? With the limit of the sequence, you can, it looks like, so for the things inside the parentheses, when k goes to infinity, it looks like 1 over 4. And then so it looks like 1 over 4 to the k. 1 over 4, the base is less than 1, so then we have the exponential function going down. So you can see this guy goes to 0. So the limit of the sequence is actually 0. Okay. So which means we should go to the second step. So you can see here is everything to the power of k. If you see something like that, use root test. So root test, we have the q for the root, so r for the ratio, and q for the root. Okay, so it's the limits, and then you take the k root of a sub k, absolute value. But here, because it's positive, you don't need the absolute value. So what is that? So we have, oh, maybe this is too long. Okay, let's see. So we have k to the fifth plus 3 e to the k plus 2. Oh, I just realized I make a mistake. What mistake did I make? So this is actually a very common mistake. Look at the dominant terms. The dominant terms is that k to the fifth? No, the dominant term is exponential term. So this guy is not 1 over 4. This guy is actually 3 over 5. Okay. And let's see. Oh, okay. So actually, let me change the problem a little bit, because here if k are okay, it's okay to have a negative base in this case, because k are integer. Okay, so but if k is like square roots, we don't allow negative numbers in the base. But in this problem, because k goes from 1 to infinite and k are the natural numbers, so it's okay to have negative base. Okay, negative number in the base. Okay, but still 3/5 is less than 1, so if it's like an exponential function, is gonna be like that. Okay. All right. Next, so what happened with the negative inside? It's just gonna be some point. Sometimes the point is positive, sometimes the point is negative, sometimes the point is positive, sometimes the point is negative. So it alternates. But you can see the limits. The limit still goes to 0. Okay. All right. So let's continue. So we have 4. K to the fifth minus 5 e to the k minus k. Okay, so to the k, this is a sub k. And then when you take the k roots, what happened? They cancel. So we only have the things inside the parentheses. So k to the fifth, 3 e to the k. Oh, I forgot absolute value. So the absolute value should be outside of a sub k. Okay. Okay, so now what happened? Which one is the dominant term? So this guy are the dominant terms, okay? And also because of the absolute value, so we will get limit k goes to infinity. Yeah, so you say dominant term of numerator is 3 e to the k. Dominant term of denominator is negative 5 e to the k. Okay, but because of the absolute value, we just get 3 e to the k, and the negative 5 now become positive because of the absolute value. And e to the k cancel, we have 3 over 5. Okay, so our answer is 3 over 5. Well, that is less than 1, okay?
Hi
so
everyone. Today let's talk about sessions 8.5. The ratio.
Sorry, I was processing another video. Okay, so because the root is less than 1, so we have the series converges by the root test. Okay, part B.